Hello students, in this video we are going to discuss about the one of the chemical reaction of aldehyde and ketone, that is nucleophilic addition with loss of water. This reaction, here there is an addition as well as the elimination is also taking place. Therefore nucleophilic addition with elimination is taking place. That is the reaction of aldehyde and ketones with the nucleophile, with the addition and also with the loss. As in the previous video, we have already classified the type of reaction which we need to discuss for the aldehyde and ketone, that is nucleophilic addition reaction, nucleophilic addition by loss of water, oxidation reaction, reduction, reaction due to alpha hydrogen and some other reaction. So in the previous audio we have already discussed this reaction, that is nucleophilic addition reaction. In this video we are going to discuss about one of the chemical reaction of aldehyde and ketone, that is the reaction which is called as nucleophilic addition by loss of water. That means addition is also taking place with the loss of water. First, the addition of ammonia and its derivative. That means in this we need to discuss some of the nucleophiles like ammonia and its derivatives, its addition with the aldehyde and ketone with the elimination of water. So first let us take the general representation of aldehyde and ketone, that is the carbonyl group. So generally we are representing the derivative of ammonia in this way, that is H2NZ. H2NZ. How we come with this formula? As you are already knowing the formula for ammonia, NH3. From this I can write N, that is NH2, and one H is there. So in this place of H, we are generally representing this as Z. So depending upon the group which is placed at the place of Z, we can write the derivative of ammonia in this way, that is H2NZ. So here what will be the Z that we will be discussing in this video session itself. So the reaction of this, that is a general reaction we are writing here. That is the reaction of aldehyde and ketone, that we have taken aldehyde and ketone in general representation form, and we also taken the derivative of ammonia is generally we have taken in terms of Z. Now if this reaction is taking place, that is the nucleophilic addition is taking place, so it is taken in the same, we can do this one in the same way how we have done for the others, that is a nucleophilic addition reaction. Now in this case, because NZ, that is NHZ, here this we can write, rearrange, we can this in this way. From this one H you can separate it. So when one H positive is separated, so what is remaining now? That is NHZ is remaining, that is negatively charged. So that we can separate in this way, that is H2NZ, we can write H plus NHZ minus. So that means the positive part is one H positive, that is get attached to the negatively, partially negatively oxygen, and NZ negative get attached to the partially positively charged carbon. So what will be getting the product here? That is an intermediate which is formed here, that is this product. As I told you, you have to rearrange this one, just rewrite this one in this way, that is H plus and NHZ minus, just rewrite in this way. So the positive part H, that is get attached from this oxygen, therefore we are getting OH here, and NHZ minus, that is negative part of this derivative, that is attached to this carbon. So that is, we can see here, this is attached to this carbon. So in this way you have to do this one. So no need to by heart, just remember which is the positive part, that you have to attach to the negative part of carbonyl group, and which one is the negative part of the derivative, that you have to attach to the partially positively charged carbon of the carbonyl group. So here there is a loss of water. Now how we can remove the water from here? That is OH from here and 1H from here. That is water is removed because in this addition is taking place. Now this is the product, that is the addition product, and with the removal, that is the elimination of water is taking place from this one. So what will be getting the product? Will be getting the product in this way. So here generally the Z can be taken an alkyl group, aryl group, OH, NH2, C6H5NH, NHCO, NH2, etc. can be the Z. And this water which is eliminated, that is written here. So this is what we are getting the product. So I tell you how that you can write this product without this intermediate. That is, just learn this general equation, that is carbonyl group plus H2NZ. Now how you can easily frame this product directly, that I will tell you. That here just oxygen and 2 hydrogen from here, remove it. So when you remove it, this one, that is one water, that is water is the side product that is formed here. How we got this side product? With the removal of oxygen from here and the 2 hydrogen from here. So water is removed. Now what is remaining here? That is a Z is remaining here, one Z and one N. NZ is remaining. So that's why NZ is remaining, that is with the double bond which is on that carbonyl group, that double bond is there. So you are getting this product. So in this way you can easily frame the product, but this is only the way you can make the product very easily in this way without going into the intermediate stage. But here actually what is happening, first addition is taking place, that's why you are getting this addition product, then only the elimination is taking place. First the addition, then the elimination is taking place, then we are getting this product, not directly. But in order to write the product very easily, when we'll be getting a question on this area as complete the equation, so the best way is to do in this way, remove this oxygen and 2 hydrogen from here. What is Z here? Z can be any alkyl group, it can be an aryl, it can be an OH. For example, if it is an OH, how we can write? What will be the OH? For example, if Z is OH, here it is OH. So this one will be, for example, we'll be taking the reaction with acetaldehyde, CH3CHO plus NH2OH. So again you can do in the same manner, that is remove the water. How you remove the water? O from here and H2 from here. So what you will be getting this product? But here what is Z? Z we have taken OH. So that is you have to write in the place of Z, you have to write a OH, that is OH. So this is the way to remember the equation, that is once you learn the general equation, you can write the equation for any of the reactant that is given when the Z are of this way. So better we can learn this in a tabular form that is given in the textbook in this way, that is C double bond N Z, that if Z is H, that is if the place of Z, what is actually that compound is the reagent which we have started, that is ammonia. How it is ammonia? Because what we have already learnt the equation, that is a general equation, this equation we have learnt. So if Z is H, H means this Z, if it is H, now what is this actually? This is ammonia. So if Z is H, so here what will be the product formed in the place of Z? We have to keep H. Now what is this compound is called now? It is called as imine. So that is what it is explained in the tabular form, that the name of that compound is imine. Similarly, when Z is R, that is an alkyl group, then what will be the name of the product? That is the substituted imine, which is also called as Schiff's base. That is very important reagent that is used in the functional group analysis, Schiff's base. And similarly, if OH, if it is Z is OH, then the name of the compound is hydroxylamine. What is hydroxylamine? That is NH2OH is called as hydroxylamine, where the Z is H. So where the Z is OH. So at the time, what will be the product form? That is called as oxime. And when the Z is NH2, that name of the compound is hydrazine, that is a reagent, but the product formed after reacting with aldehyde and ketone are called as hydrazone. Look at here the name, hydrazine is giving rise to hydrazone. Similarly, next we have phenylhydrazine. Look at here, hydrazine and phenylhydrazine. What is the difference here? It is NH2 and this one is NHC6H5. That is phenylhydrazine. Phenylhydrazine, what is the product name? That is after reacting with the aldehyde and ketone, the product name is phenylhydrazone. Next, that is 2,4-dinitrophenylhydrazine. That is, if the reagent is 2,4-dinitrophenylhydrazine, then the product which is formed here, that is shown here, and the name of the product is 2,4-dinitrophenylhydrazone. That means hydrazine word you have to change with hydrazone. Similarly here also hydrazine you are changing with hydrazone. And the last one is semi-carbazide. This one, that is semi-carbazide. That is the reagent, and when reacting with aldehyde and ketone, it formed the product that is called as semi-carbazone. So this is the table which is actually given in the textbook. So once you learn the general equation, that is this equation, you have to learn it, and in the place of Z you can keep an alkyl group R, you can keep an aryl group, that is C6H5, you can keep OH, NH2, anything you can keep, and you can frame the product in this way. But the name of the product and the reagent is given in this tabular form. So all of you take one example of an aldehyde, that is acetaldehyde, CH3C double bond OH. All of you do these reactions with the acetaldehyde, and one of the reaction, that is one of the ketone we can take, that is acetone. So all of you do these all reaction with the ketone, and the name of the product that is formed here, that will be these which is given here. So this is all about the important reaction which we have discussed, that is nucleophilic addition with the elimination of water in this video session. So all of you try this example, and all these equations is taken from the textbook. So better note it down from the textbook instead of note it down from the video. Better to consult the textbook and note it down clearly and do the different examples from the table which is given in the textbook. So this is all about this video. Have a nice day.